Student, today we are going to discuss your chemistry 4th chapter, carbon and its compounds. Okay, student, some elements exist in various forms. These forms have different physical properties but have the same chemical properties. They are called allotropes of the element. Carbon, phosphorus and sulfur have allotropes. Okay, so student, allotropes are the forms of the same substances which have different physical properties but have the same chemical properties. Okay, diamond and graphite are allotropes of carbon. The differences in the physical properties of diamond and graphite are because of the manner in which the carbon atoms are arranged, and their chemical properties, however, the same. They both burn in air to form carbon dioxide. Diamond is the hardest natural substance, we know that. There are some physical properties of diamond, that is, diamond is one of the purest forms of carbon. Diamond is represented by the same symbol of carbon, that is C. Diamond occurs in all shapes and sizes. Diamond is found in igneous rocks. Okay, and diamonds are formed under intense pressure and heat. It is found in the igneous rock and gravel, but is unevenly distributed. In India, diamond is mined at Panna at Madhya Pradesh. The most famous diamond of India, which is Kohinoor, okay, and it is the jewel of the royal crown of Britain now. Okay, student, in diamond each carbon atom is joined to 4 carbon atoms. We know that valency of carbon is 4, and so carbon has 4 open hands, and it can hold in this open hand various elements. It may be carbon, it may be others, any kind of element. And in arrangement of diamond, each carbon atom is joined to 4 carbon atoms. Okay, and this gives diamond a 3-dimensional structure and hardness also. As there are no free electrons, diamond is a bad conductor of electricity and it is good conductor of heat. Okay, uh, when we think of diamonds, we think of sparkling jewelry. Yes, and diamond has other important uses also. Diamond tipped tools are used for cutting and drilling rocks. It is used in spacecraft to make radiation proof windows. Okay, and graphite, the black slippery solid that is a major component of pencil lead, is also pure carbon, and pencil lead or graphite has been used to writing since the 16th century. The word graphite is derived from the Greek word graphein, which means to write. And in graphite, each carbon atom is strongly bounded to 3 other carbon atoms in the same plane. Thus, each carbon atom forms part of 3 hexagons. This leaves each carbon atom with 1 loosely held outer electrons, which enables graphite to conduct electricity. Okay, and carbon atoms are arranged in layers. The weak forces between each plane of hexagons allow them to slide easily over one another, and this makes graphite soft. Okay, graphite is used as a lubricant, graphite used as a graphite grease, as a crucible to melt metals because of its high melting point, that is 3500 degrees centigrade. Okay, and graphite is used in electric motors. It is used for making pencil lead. Okay, and pencil lead is made of graphite. Graphite is mixed with wet clay in required quantities to give the required hardness. Okay, the pasty substances is then rolled and hardened by heat. Okay, student, now we compare the properties of graphite and diamond. In graphite, each carbon atom is joined to 3 other carbon atoms. But in diamond, each carbon atom is joined to 4 other carbon atoms. Okay. In graphite, the carbon atoms form flat hexagonal layers. But in diamond, the carbon atoms together form 3-dimensional structure. Graphite is a greenish black and opaque substance, but diamond is a transparent substance. Graphite is lighter than diamond and is soft and slippery, but diamond is the hardest substance, we know that. Graphite conducts electricity because it have some free electrons, but diamond doesn't conduct electricity due to lack of free electrons. Okay, graphite can conduct heat but not extend, but diamond is very bad conductor of heat. Okay, now student, we discuss about covalent bond. Okay, covalent bond. The resistivity of elements is explained as their tendency to attain a completely filled outer shell. Okay, and that is attain noble gas configuration. These noble gas structure are thought of as being in some way a desirable thing for an atom to have. Okay, and elements forming ionic compounds achieve this by either gaining or losing the electrons from the outermost shell. Okay, in carbon it has 4 electrons, we know that, and in its outermost shell carbon contains 4 free electrons and needs to gain or lose 4 electrons to attain noble gas configuration. Okay, so if carbon were to gain or lose electrons, if carbon gain 4 electrons forming C4 minus anion, okay, but it would be difficult for the nucleus with 6 protons to hold on 10 electrons because it gains 4 electrons more. So now its number of proton is 6 and electron is 10, and that is 4 extra electrons. So it is very difficult for the nucleus, okay, to hold 6 proton with 10 electrons, 4 extra electrons here. But if it could lose 4 electrons forming C4 plus cation, okay, but it could require a large amount of energy to remove 4 electrons, leaving behind a carbon cation with 6 proton in its nucleus, holding on to just 2 electrons. Okay, so carbon atoms overcomes this problem by sharing electrons with other atoms of carbon or other atoms of other elements. Not only carbon but many other elements form molecules by sharing electrons in this way. Okay, and the bond is usually formed between the 2 non-metallic elements in a molecule. The 2 positive nuclei due to the protons of both atoms are mutually attracted to the shared negative electrons between them, the covalent bond. This due to shared electrons, they form covalent bond. Okay, student, they share the electrons in a way that gives a stable noble gas configuration. Okay, and the bonds which are formed by the sharing of an electron pair between two atoms are known as a covalent bond. Covalently bonded molecules are going to have strong bonds within the molecule, but intermolecular forces are small, and this gives rise to low melting and boiling points of these compounds. Since the electrons are shared between the atoms and no charged particles are formed, such covalent compounds are generally bad conductors of electricity. Okay, so depending upon the number of shared pair of electrons, the covalent bonds are of three types. Single covalent bond involving only two pairs, that is two electrons shared here, or one pair of shared electrons. Okay, double covalent bond which involve two pairs of shared electrons, that is four electrons shared here. Triple covalent bond involving three pairs, that is six electrons shared. Okay, now student, we discuss about single covalent bond. Okay, student, when both the combining atoms which are short of one electron form the stable electronic configuration, that is 8 electrons except in case of helium which has 2 electrons of the nearest inert gas. Except helium, all the noble gases contains 8 electrons in their outermost shell or valence shell. Okay, and other atoms of the substances, they want to be get the nearest noble gases configuration. Contribute one electron each to pair of the electron which is equally shared by both the atoms. The bond resulting from the equal sharing of one pair of electrons is called single covalent bond. Single covalent bond means the equal sharing of one pair of electrons. Okay, for example, single covalent bond formed between two atoms such as hydrogen. Okay, each hydrogen atom, atomic number of hydrogen is 1. So its atom has a single electron in the valence shell, and the valence shell, that is outermost shell, is short of one electron from the stable electronic configuration of the nearest inert gas or noble gas, that is helium, which contain 2 electrons in its outermost shell. Okay, so thus when two hydrogen atoms combine to form a hydrogen molecule, that is H2, each of the hydrogen atoms contribute its single electron to form a pair of electrons and acquiring the stable electronic configuration of helium. This electron pair is shared equally between two hydrogen atoms and lies between them. This results in the formation of single covalent bond between two hydrogen atoms. Okay. Double covalent bond, when each combining atom contribute 2 electrons and the two pairs of electrons are shared by each atom, a double covalent bond is formed. Okay, and double covalent bond is shown conveniently by two lines joining the atoms. Each line represents one pair of shared electrons. Oxygen, ethylene, carbon dioxide, they contain double covalent bond. Okay? And triple covalent bond between two atoms is formed by the sharing of three pairs of electrons, in which each atom contributes 3 electrons to the shared pairs. A triple covalent bond is shown by 3 short lines between the two contributing atoms or two combining atoms. Common examples of triple covalent bond is nitrogen, acetylene. Okay. Student, conditions for the formation of covalent bond. There are so many conditions for that. That is, covalent bond usually formed between the same or different atoms with less than 8 electrons in their valence shell. A covalent bond formation is favored when the atoms have 5, 6 or 7 electrons in their valence shell or outermost shell. By sharing their valence electrons, the combining atoms complete their octet in the outermost shell and achieve the stable electronic configuration of the nearest inert gas. Okay. There are so many characteristics of covalent bonds also, that is physical state, melting and boiling point, stability, conductivity, reactions. Okay. Physical state, in general covalent compounds are liquids or gases under normal conditions of temperature and pressure. Solid covalent compounds are also formed, but they usually have high molecular weights. For example, chlorine Cl2 with a molecular weight of 71 in a gas, bromine with a molecular weight of 170 is a liquid at room temperature, and iodine with a molecular weight of 254 is a solid. So molecules in a covalent compound are held together by the weak forces called van der Waals force. Okay. Most of the covalent compounds exist as molecules with which are held together by the weak van der Waals forces. Okay. And therefore their melting and boiling points are low. A few covalent compounds such as carbon diamond, they exist in the giant three-dimensional structure and have the high melting and boiling points. Covalent compounds are soluble in non-polar solvents, usually organic solvents like benzene, carbon tetrachloride, chloroform, nitrobenzene. Okay, and polar covalent compounds may however dissolve in the polar solvents such as alcohol, water. Okay, certain covalent compounds possessing giant three-dimensional structures, practically insoluble in all solvents like quartz and diamond. Okay. Covalent compounds do not conduct electricity either in a state of solution or in the molten state, since there is no ions or electrons to carry the current. Covalent compounds contain molecules, not ions, in the electrovalent compounds, and therefore their molecules participate in chemical reactions, and these reactions are called molecular reactions. The molecular reactions are very slow as compared to ionic reactions. Okay, student, in your next class we discuss the different structure of the compounds which contain single bond, double bond, triple bond. Okay.